Hello everyone, welcome back. This is the third and final video where we walk you through several features of our Cinnamon framework using our example project. You can find the link to the project as well as to the framework itself in the video description. If you haven't watched the first two videos yet, we highly recommend checking those out first. For everyone else, let's get started. What are we covering today?
Today we'll be working with the runHoming, runAutomatic, and runManual methods. We want to take a closer look at these methods, specifically because of the process logic implemented within them. All function units extend abstract mode node and can be considered separately. We already explained this earlier. We will start with runHoming.
But before that, let's take a look at our main. Here we have our base HMI, and our custom mode condition is set to 0. What the custom mode condition is, will be explained later in another video. What is important for now is this: here we can define conditions that must be fulfilled in order to start an operating mode. If the custom mode condition is set to 0, a hidden default mode condition takes effect. This default condition defines that the operating modes manual and home can always be executed. All other operating modes can only be executed if the root node is in the home position. This means that runHoming must be executed first before we can execute runAutomatic.
So let's start with this method. As an example, we will look at the runHoming method of our supply unit. The first thing we see here is a reference to our cycle manager. The cycle manager is our step chain controller in structured text. Every run method has an execute, which is a bool. With a rising edge, the method is executed. This is handled for us by the op-mode handler. When execute changes from false to true, the first step is called the init. The case of instruction controls which step we are currently in. Once the first step has been processed and returns a success, the step counter is increased by 1. This is done via the proceed method of the cycle manager.
The cycle manager has 4 different ways to advance the step. Proceed is one of them. As mentioned before, it simply increments the current step by 1. There is also proceed with. Here, a specific step is defined that should be continued with. This does not necessarily have to be the next sequential step. Then there is the evaluate method. Evaluate expects a single execution state as input, for example busy, error, and so on. As long as busy is received, the program remains in the current step. As soon as success is received, the current step is increased by 1. If evaluate enters an error state, the program transitions into the error step. The error step is a default step. When we are in the error step, the cycle manager returns an error. There is also the execute command method. This method expects an iCommand as input, meaning a class that implements iCommand. When execute command returns success, the step chain advances by 1 step. Since we will take a closer look at our cycle manager in another video, we will stop here for now and move on to the step chain itself.
In our first step, step.init, internal data is reset. Once this is done, the current step is increased by 1, using proceed. And the step chain continues with the step home portal. Here, evaluate is used. We need a success from the method moveToPass in order to continue in the step chain. If we look into the method, we can see that it also contains a step chain. Since this is a cyclic node, an instance of the cycle manager was declared here because cyclic nodes do not have a node cycle manager. The first step here is again init. In the following step, for commands are executed simultaneously. Only when all of them are in success, is success returned, and the step home saucer can be executed. Here, step.next decides which step to continue with. The SEL decides where to jump, If the gripper is still holding a part, it first jumps to open gripper. If it is not occupied, it continues with step.success. So either the gripper is retracted first and, after a success, the process continues with step.success, or after home saucer it continues directly. Here's an overview of the steps we just went through. Now, isInHome is set to true. And just like that, our runHoming returns success.
Now let's take a look at an interesting example of a runAutomatic method. Therefore we look into our distribution unit. As a quick reminder, this is the part of the production line we are talking about. The first step is again our init step. Here, the stopper in front of the camera is extended, and the direction of our conveyor is set to forward. The leave defines that this instruction is executed only at the end, after all other steps have been processed. It switches the conveyor on. The counterpart to leave is enter. This instruction is executed before everything else is processed. In the next step, wait for cupcake, the system waits for a cupcake to arrive. If the sensor is occupied, proceed is used to move to the next step. The first line in this step defines how a stop request is handled. In this case, the cupcake would remain stopped at the station. In the next step, check type, a stop request is ignored. This means the cupcake is not stopped here, but continues through all remaining steps until the end. In this step, we receive an image via an analog input from our simulation, which is then evaluated. Based on this, the type of cupcake is determined. This is followed by a case distinction, or more precisely, a branching. If the cupcake is of type vanilla, proceed is used to switch to the next step, send to Croco 1. If the cupcake is of type chocolate or strawberry, proceed with is used to switch to the step, send to Croco 2. All other possible cupcake types switch to the step send to catapult. The leave at the end of the step stores the camera result to the database. This data is required for our HMI and is stored as a measurement.
Let's take a look at the step Croco 1. Here, several methods are expected to return success before continuing with wait tablet gone. Let's look into send cupcake. First, the camera stopper opens. The method separates and sends a cupcake from the camera position to the main conveyor where it will be branched. The let pass method lowers the LTU and lets the cupcake pass through via the main conveyor. The branch to this method is a bit more complex, so let's take a look inside. This method stops a cupcake and transfers it to the side conveyor of this branching unit. Another step chain is triggered. The LTU is moved to the middle position. The system waits until the cupcake has arrived and is stopped. This is detected by a sensor. If no cupcake arrives within 15 seconds, an error message is displayed in the HMI indicating the absence of the cupcake. If the cupcake is present, a lift is executed and the LTU moves upwards. The leave at the end of the step starts the conveyor in the direction of Croco. In the step transfer cupcake, the cross transfer is started using the enter. In the step wait cupcake gone, we wait until the cupcake's tablet has left the LTU. It is then evaluated whether the tablet should be recycled or not. If it should be recycled, the process continues with the step remove tablet. If not, the step returns success. In the step remove, the direction of the conveyor is set to backward, and the system waits until the tablet has returned. This is detected by a sensor. In the next step, the system waits for 0.5 seconds to ensure the cupcake is fully aligned on the LTU, before moving on to the final step, in which the LTU is lowered again. Branch to this returns its return value.
Croco 1 and Croco 2 now wait in the step wait tablet gone until the tablet is in the trash. Catapult does not. Catapult switches back to the step wait for cupcake. Croco 1 and Croco 2 do the same once the tablet is in the trash. This creates a loop.
Our runManual method is empty in this project. However, you can use runManual of mode nodes for motion sequences that consist of multiple components, for example to move to maintenance or service positions, to adjust partial processes, or to execute test sequences when needed. You should now have a solid overview of the Cupcake Factory example project and how we use Cinnamon within it. In the upcoming videos, we'll take a closer look at individual Cinnamon libraries and elements in more detail. You know what to do if you don't want to miss anything. Hit the bell. Until then, have a great time.
Bye.
Bye.